is a fraction in scale of what the broader application is.
Yeah, and of course that's,
So in other words,
it's got to be in line with how the system's wired up. Some
Right.
systems aren't forgiving to that. Or
right. So to a point that Nasser made, just if there's an 80 unit facility in terms of order of magnitude, just taking one sub panel and putting a box there to prove case as a proof of concept might not necessarily answer the broader need.
So
But
knowing that several.
But it will demonstrate that the SP, because if you take it and you put the SP1000 on that sub panel, if you want to do it in stages, correct me if I'm wrong, Philip, if you put it on that sub panel and you get the reads off the dashboard of the SP1000 and you compare it to the reads on the meter, you can see, and then you can turn up remember you can turn the capacitors on and off within the SP1000, correct?
Right.
So you turn the capacitors on, it runs for an hour or whatever, and you compare it to the meter, and you measure it before with the meter, and then you put the SP1000, you measure the meter along with it, so you have an independent read and you have the SP1000. So it's going to show, it's going to validate that it's doing what you're going to tell it's going to do throughout the whole facility. It's not going to make a difference within the whole facility. It's not going to make a difference on the electrical bill, but it is going to show you.
Well, it might, depends on what the concentration of harmonic loads in that one section is.
So you
Now,
have to
we
be
could
careful
do-
with your sections.
We could do the engineering support and analysis for that one section. At the same time, we do the engineering and support analysis for the entire plant. Okay, so we use this real data to support our analysis here at another level that's saying, okay, if we do this and roll it out 10 more times, this analysis is going to predict what we can get in our savings and improvement in power quality. We've demonstrated on a small scale, we're controlling cost here, but we have backup here from the engineering analysis level to show the customer that, yes, we've increased your confidence again that when you multiply this by 10, this is what you're going to get. Because if you go in there without an engineering analysis, and if you try to convince him that, if you do this 20 more times, he's going to question that because it's a new technology and he don't know anything about it. But you want to give him the feeling that you've done your homework, so that when you go in and do a broad scale sale and installation, that we're really going to be able to reach the levels
Right.
that I can get
But
back here on the meter.
placing that one unit though is,
Well, it's not just one unit.
no, I know, but say you have one panel might have several sub panels associated with it, and only one of those panels really has the heavier load.
It's possible.
Right,
Yeah,
so-
that's why you need to look at the one line diagram.
Yeah, so I feel like what I really like to do is hook up my computer and actually show an electrical line diagram and have you walk us through that. I think that maybe would benefit everybody.
Walk you
Benefits
through
me.
what?
What you were
Your
basically talking
analysis
about,
of
like
it.
saying an analysis component of.
Well, I can't do an analysis on the board because it's a computer analysis. There's thousands of calculations that the computer will do. And I can talk to you about how it's done. That's why we have the algorithms to do it, is because it's these guys used to do this by hand when they were putting in the static capacitors years ago. They would do all these calculations by hand, hours and hours of scratching until they, had computers so they could do this.
We need to forget about that first meeting here.
Yeah, it's such a good.
So there's, I'm coming up with new ideas in my head based on what feedback you guys are giving me about how to get the customer on board quickly. That's mine.
That's yours.
Yeah. How to get the customer on board. I mean, you don't want to push the sale too quick. He's going to get suspicious, but you got to go in there. You got to have some intelligence with it. You got to have some
There's no such
background with
There's no
it.
such thing as quick. Like quick for me is a 6-month turnaround.
Yeah, I know.
That's quick.
Right.
But it's,
We can shorten that down.
we say that, but between
It's because you haven't been dealing with people who are. See, I'm experienced in power quality not just from the application side of it, but from why things don't work right side of it. Because there's many manufacturers who
you're
make
the
power
exception to the
quality,
rule.
yeah, I know,
Yeah, so
equipment that don't
The
work right,
majority
and people
of
buy
people
it and
have
they
to
get
deal with-
disappointed. Huh?
have understand the problem somewhat, but they're not near a point of pain yet.
Yeah,
So I have to articulate
yeah.
their situation.
You have to have a little foresight, and by learning this, you can, if these are the problems that you're having, then this is what's gonna be down the road for you. So you have to have a little foresight with your education on that.
But we'll figure out a system that works better for you, you guys in terms of support and time management and getting the customer to a level where, you know you're really close to making a sale like 30 days away. On a managed risk, that's the key there. You gotta show the customer that you are into managing risk because you're taking a risk just like they are, right?
Oh yeah.
Yeah. You're putting your name out there on the line saying that I'm gonna sell you this $1 million worth of boxes, they're gonna perform. Because you don't want a callback. You don't want to have to go back and hire somebody to take that stuff out.
Just
And
to
you-
go out there.
And I'm not trying to scare you, okay?
No, I know. But there's, so like for local
I'm
sales,
trying
so
to help
domestic
you.
sales, no, I'm happy with that. And I actually appreciate the fact that you are grasping it.
Unfortunately, I've
Essentially-
been drug into situations that other people have caused that I had to go in and figure
Right.
out. A finger pointing thing. That's
Right.
what,
But,
that's
but
one of the things
I have
that we
to
did
deal
notice.
with, so I'm dealing with on an international scale.
Yeah.
So I have to magnify any situation because of the time differences, cost of shipping, cost of just traveling.
Language
there and
barriers,
back,
all those things.
language barriers. So all of these issues tied. I mean, one facility I spoke to, they have about $200,000 a month electrical bill. They have 4 meters. I mean, I was talking to a guy that was from India who barely spoke English, but had a staff. And so these are the limitations you have when you're trying to explain the technology to individuals. And I have that
Well,
cost.
Connie and I have talked about this, and if I may, I'm going to talk about what I've talked about with Steve. Steve, is
That's
that
up to
okay?
you and
Yes, sir.
Steve.
About taking a facility that you feel is a good candidate for this kind of technology
Right.
and working through this process cautiously,
Yeah.
on a guarded approach, because I have things I'll set in place where we don't step in a mud hole somewhere, to create a solid case study that has engineering support behind it on a good industrial level or a good commercial level, and you can use that as a tool to go out and demonstrate to people, and you can sanitize it, take the names off or whatever.
Right.
But those kind of stories really hold a lot of value in
Which-
getting the customer to realize this is real stuff and I need to invest in it.
Right.
That's what he and I are working on, in a sense. So, do you want to add some?
Which
stuff
to your point is only reasonable or justifiable for a subsegment of your customer base, right?
Yeah, of
'Cause
course.
you wouldn't do that for the guys that might not appreciate the broader scope of the problem, or maybe think they've already addressed the issues with their filters or with their one-off solutions.
Because at the end of the day, you want that customer to write a letter back to you and say, this guy really did a great job, we saved X amount of dollars, we've proven that our power quality's improved. You want that kind of letter in your notebook. In addition to the story.
Yeah.
Because that's exactly what we would do at Emory, is help utilities develop good case studies, solving problems. The utilities want to be known for solving the problems. So they would, come in and do that with us.
And
And
not reducing their cost.
sometimes. I mean, reducing the cost of downtime and equipment is usually reducing cost.
Yeah, that's
Even if
true.
they only reduce sometimes the goal might not be to reduce the cost of electricity because power quality causes so many problems for plants. Put them out of business if it's not under control.
One thing I would say now, sir, is another thing that we're talking about, I don't mind saying this, is that the next step of that process would be, and we're exploring this, for which customers might it make sense to do a world-class audit? That's obviously at my expense, because the potential warrants that upfront investment. If you can deduce that the probability of close, if you do a badass introduction and you explain it in terms that are robust and that are really clear on technical and financial terms, then you can say, based on their level of engagement, well, shit, I mean, these guys are, I can quantify the probability of close to whatever, over 1 and 2, a 50% chance of close. then you can say, well, it's a multi-million-dollar application. Taking an upfront investment and ensuring that the probability keeps growing as we continue to, as we deliver value through the audit process. That kind of starts making sense as a consultative sale,
Right. Yeah.
where the lead time is multi-month, but the size of the prize warrants the.
No, I agree.
Yeah.
So here's what I was talking about earlier, the analogy. This is what we don't want. This is what does work for us in producing products and lighting buildings and all that. This is what we're given to work with. So if we cut down on this and we increase this, which we can easily add more load, this is costing us, in some situations, a lot more than this is even costing if you get really bad. I mean, it can be overwhelmingly expensive. It'll take but a couple of months to figure that out.
It'll
The
take you longer
accountant's
to
coming
get
down
drunk,
somebody's
right.
throat. How come I got an electric bill for $800,000 when it's only supposed to be $2? I'm just exaggerating a little
Well, if you
bit.
got more foam, that means you have more beers to get drunk. So yeah. I mean,
So, anyway, that's the, and then of course this one. It's obvious. Wasted reactive power.
It's a good one.
So now we're down to the triangle part. Okay, this is parent power, what we're given to work with, what we have, what we can use to accomplish our goals in the plant, and then of course the reactive power. This is a bad situation. You can see that this is almost as much as this. This is the way we relate three quantities in a triangular form. This squared plus that squared equals that squared. Diagram there. But now we can improve that situation, and of course the power factor is the cosine of this angle. So it's really difficult. It's kind of misleading to say that a bigger angle is worse, but it's the trigonometry thing. So if we take the cosine of that angle, it's going to be a very small number versus the cosine of that angle, which is going to be a number closer to 1. So this is a situation we want to get to where we're managing our reactive power. And as the load changes in the plant, this triangle is dancing everywhere, going up and down. It's changing dynamically. I've never seen an instrument demonstrate it that way, but yeah, I guess it could be done. But there's other ways that we use to demonstrate that. So for the SP1000, customer starts with this, okay, and by applying the SP1000, we get to the better situation. The real power may not necessarily change, okay, but the reactive power change. There's different scenarios for these triangles, and we're not going to get into the details of it, but we can increase our capacity and drive more load and reduce reactive power at the same time. It's a very dynamic thing, but
so it's really
It's all in the
reducing your
details.
costs based on the reactive or the reduction of the reactive. Because right now you're paying for both, like the foam and the beer.
yeah, I mean, over here, we've got a fixed load we're working with. What we don't want to do, because in a situation like this, we've got to have more available to be able to drive our equipment. But if our reactive power is bad, then we're paying a lot for this in infrastructure, and we're paying a penalty on this to be able to use this in the plant. This is a much better approach. We're still able to run our plant with the load we have, but we're managing our power, which means we've essentially taken the stress off of our plant, therefore I can add more load. Because people are all the time wanting to expand these buildings. Benefits of SP1000 applications: fewer equipment failures, boosting the power factor, reducing system losses, enhancing voltage regulation, because as the reactive power fluctuates, the higher it gets, the more difficult it is to regulate the voltage. Okay. Reducing the system capacity, releasing the system capacity for new load, and deferral of capital expenditures for electrical system upgrades. Anytime one target area of customer that might be really good for you to, and this needs to be in your questions like I mentioned before, is that customer planning on an expansion in the next 5 years? Expansion adding on to the building they have.
Yeah.
Or taking a piece of that building and reworking it to do something different, do a different process, and that process might require more power. Well, guess what? The building might already be maxed out at load. So if they're planning on doing something like that, you can go in and install SP1000s across the building, and they may be able to add that new process in the plant without having to spend that extra $500,000 on upgrading the infrastructure.
So I have just a quick question. How would the SP1000 be applied to a new construction? So let's say we're in the process of designing a building that we want to build.
Yep.
How would that get integrated? How would the SP1000 be integrated with? Because you're saying you need the audit and the walkthrough and all that.
Well, first of all, you want to start with the engineer's concept of what the electrical system is going to be. So they'll have a one-line diagram for that. Hopefully you want to get that at somewhat of a mature level, so it's not something that's going to change 30% 6 months down the road. But you don't want to get too close to the end, because then you can't integrate the SP1000 technology. I mean, you can, but I think it would be simpler if you integrated that while the building's being wired up.
Because I'm trying to.
Because what you could do is you can get a list of equipment that customer plans to use there.
Mhm.
And they may be moving their operations from one city to another, or they may just be adding a building and in their suite of buildings and going to do something different. Okay, but they'll have an idea, because they have to tell the utility how much load they're going to have, and they have to give them, well, how much is your load going to fluctuate? They got to be able to tell them something so they know how to size the service
Right.
and what kind of circuit to put them on. So there'll be some knowledge there of the building infrastructure and the loads, the dynamics of the loads, which will allow us to help you formulate a list of SP1000 equipment for that new building. And then they can start managing their reactive power from the get-go.
Because I'm trying to think if.
That's a very good question, though.
There's a bid for building a new all services hospital.
Perfect application.
And so, let's say like a Kaiser building, because they do everything there.
Kaiser permanent.
Yeah, so let's say they're in the process of, they want to develop it. At that point in time, do we get the electrical diagrams and what they're thinking? And then we would provide that for you?
Yeah, meet with the hospital. Tell them what you're interested in doing and how it can help them. I mean, we'll have to talk about what's the best way to
Yeah,
help
we'll talk about
these
the
guys.
logistics on it.
But yeah, get in as soon as you can. Because these hospitals, well, number one thing about hospitals, they have, the imaging departments can cause a lot of power quality problems, because that's where the large loads are. Okay, that and the HVAC support for the building. Okay, but hospitals, before the times of data centers came about, were the building that had the most nonlinear loads per square foot of any other customer facility. The data centers blew them right out of the water, because they got stacks and stacks of servers. So hospitals have a lot of nonlinear loads, okay? Think about how a hospital operates. You got fixed equipment, which doesn't move, large and small, and then you got lots of portable stuff. I'm pushing an x-ray machine from floor to floor. That's a pretty good size load, plugging it in here. So there's lots of dynamics in the hospital, and there's lots of risk involved, because in the ICU, you don't want the power to be bouncing around everywhere. Yeah.
On that note, would you be able to provide us with the idea, the points for the lead certification?
Yeah, I can write that for you. The leads are written up to, in a way that, instead of writing a specific process for everything, it's written in a way that you can apply their process to whatever it is you're doing in the building. And of course, there's certain checklists you have to go through to get the scores and all. But I can look into that. I mean, I'm not sure
I
that
talked to an
it,
architectural firm,
He
that's
asked
what
you
they
that?
would need
yeah,
to be able to write in the
yeah.
ESP.
And if we don't think that the lead process is accepting of the SP1000 technology, then I set up a phone call and join the leads group again to campaign for that. That's the way these things get done.
Makes sense.
Now with,
Of course, I have to be paid to do that, because I gotta go places and all that,
Well, that would
but it can be very effective in
con,
working in the requirements, working in the requirements. and then people become somewhat mandated to buy these
So,
things.
for
Like-
solar, so you got solar energy being harnessed in one facility, in one space. What are the applications for the SP1000? I mean, just because it's
With the
not-
PV system?
Yeah, with a photovoltaic system, if you have solar solutions, you have companies that have solar panels, they're saying, well, we're reducing our cost. Would the application of a unit help increase that efficiency of? You know what I mean? Because it's being discharged directly to a end, like, as far as I understand it, here's the solar power, here's the battery, if you will, or storage bank for that
The
energy.
panels, the inverter, and the battery.
Yeah, and then it goes straight to something. So there's not a
Yeah.
lot of interference.
Well,
Establishing an SP1000,
here's the inverter. Here's the battery,
right?
for lack of time. And of course, this ties back to the AC, right?
Yep.
That's what the purpose of this, is to decide when, you know, the power goes this way, or this way, or this way.
Mm-hmm.
Well, some of them, but anyway, this creates the harmonics, the reactive power that has to come this way,
Right.
okay? You don't want to go to the solar manufacturers and tell them they gotta, and I don't think that's what you're saying, because they're gonna say, oh, that's gonna make our system look bad. So it's the customer, you know, the customer over here, if you got a customer over here that has a high reactive power situation, okay, and he's gonna implement solar, that's a customer you want to definitely target. But you gotta figure out what their reactive power situation is, which means you gotta look at their bill, you gotta look at embedded data in the plant, if that's available, to get somewhat of an idea about how the addition of this to those buildings is gonna affect their overall reactive power situation. Because it could push it in the, I mean, it will push it in the wrong direction, but the question is how much? I mean, I'm flying into the airports and I'm seeing these buildings with solar panels everywhere on top of them, you know. That is affecting their reactive power. Because this is another one of those power supplies. This is a nonlinear load. It's just doing things a little bit differently than what some of these other are. We're converting AC to DC and DC to AC and all that good stuff. Same thing here is there are inserters and drives and everything else. It's the same action. The switching of the transistors is what's creating all this harmonic power that's hurting these buildings and costing us money.
Okay.
Does that make sense? Okay, so
Moving on, or we're doing it?
this is a good one for you. Before the SP1000, the fact that the voltages and the currents don't line up, this is our wasted power. Okay, so the SP1000 allows us to get the voltages and currents closer together, so we're reducing the harmonics and the shift. Really, the power factor is calculated two ways. There's two types of power factor. The true power factor, all right, is the displacement power factor plus the power factor from the harmonics. All right, so if I move the waveforms apart, this number goes down. All right, that's what you see here. When the current gets distorted, then that's this number here. So the fact that I have to move the current away from the voltage, which is bad, and the fact that I have to distort the shape of the current, those two things contribute to the poor power factor. So 50 years ago, we were just dealing with that, because we only had motors, light bulbs, and heaters. Now that we have all this electronic power supplies, we added a lot of mess to the wave shape, which further hurt us in the power factor. So the point is, of course, I want to make sure you know it's not just the shift in the voltage of the current, but it's what the current looks like. The closer we can get it to a sine wave, the better our power factor is going to be, and the less penalty these customers are going to have to pay. So that's what the SP1000 is doing for us in terms of the shift. I don't have a graphic to show you the improvement. I could have made one if I'd had an extra 30 minutes.
And the equivalent sort of very quick explanation of how it does this is by managing reactive power.
Yeah.
Okay.
is just not forgiving when we start twisting this wave shape. Remember, the voltage is the stimulus, the current is the response. If I kick the ball, it's gonna go wherever. I'm trying to think of a good analogy, but I think you get the idea. This is the stimulus that we're applying to the loads to get the loads to work. And then the current occurs because there's loads there. This is the response. So if the response is bad, then we're gonna have to pay for that. And that's why we have demand charges and power penalties.
Yeah.
It's because customers aren't aware, or weren't very aware, that their loads were really causing those kinds of problems and causing $1 million utility transformers to burn out. You saw this one already. Just the one on here on reactive power. So real power, reactive power. So if we don't have some kind of correction over here, then we have to supply a lot of reactive power to the loads based on what the real power is, okay, based on the nonlinearities here. But as soon as we go in and start managing this capacitance at certain points in the system, we're able to re-steer the reactive power or provide the load with the reactive power from this instead of from up here. This is an expensive place to get the reactive power from the utility. This is a more manageable situation for the customer to be able to provide his own reactive power based on his needs.
That's a great slide and a great selling statement.
If the customer is in control of their reactive power production, which is what the SP1000 allows you to do, it's going to be more cost effective for the customer because the customer is not at the mercy of the utility.
So it's really taking the reactive power and saying, okay, this MRI needs all this power right now, so I'm just gonna
Yeah,
route
you
it.
can provide your own reactive power. They're doing it with the big banks, but they're not doing it good enough. And you can't, because those banks are so big and expensive, you can't put too many of them in. Can't get them in the right places. So they're doing the best they can, but doing it dynamically. And we're doing it with the microprocessor. So that's even better because this decides when and how much capacitance to put on each phase. And all the phases don't need the same capacitance because the loads are never balanced. The voltages are never balanced.
So what about the?
So why apply the same capacitance to all three phases just because we're too lazy to put in intelligence into the system?
Why do it? Mike?
What about idle
It'd
times,
be cheaper.
like when you're not going to be using these equipment that require lots of energy or
Then
lots of power?
it won't provide a lot of correction. It don't provide a correction unless correction is needed. The first time I hooked one up, I was like, "Yeah, that's pretty cool. I can hear it correcting, not correcting." And the guy down the hall turns on the big load, and it's correcting a lot.
That's the clicking.
Yeah, it's clicking.
And you can see it on the light.
Yeah. It's a very cool system. I think it's a good technology.
It's also laggy, so I don't know if you want to explain that a little bit rather than leading
Yeah.
corrections.
You made me take that slide out last night.
I did not.
Because she wanted to be able to drop it in as her insight.
Yeah.
Come on, man.
So talk a little bit about why the SP1000 is, how it's a leading rather than a lagging. rather
Well, I'm
than
gonna put
leading,
my
why
slide
that's
back
so
in.
important.
Well, because I'm
See, he's
curious,
stealing your thunder back.
if you apply the SP1000 to a house, it's not going to do anything
Right.
because you don't have that
You
big.
don't have anything to correct really enough load. As a matter of fact, you don't want to because it has to do something, right? I mean, it's not going to
I'll
just
be
not
flipped.
do anything. So if you apply it, that's where if you apply too many SP1000s,
Show me
it's just
messages.
as dangerous as not playing enough.
Okay.
Because if you apply too many capacitors,
Well-
it is going to be a leading because it has to do something. It's not going to just sit there.
So this is the real load, okay? And the reactive power can go leading, caused by motors and stuff, or lagging, caused by capacitors. So really what's going on in the plant is doing this all the time. It's mostly up here, okay? And every time you switch on more servers, it gets a little closer down here. Or if you turn a big, massive amount of capacitive load on, it's gonna go this way. And that's what we don't want to do with too many SP1000s. We don't want to overcorrect. We want to get as close to this point as possible, dynamically, for the conditions in the plant. And at the mercy of the utility, because the utility might not feed us the voltage that's clean. It might look very nasty for a few hours. And that's gonna make the harmonics worse, because we're feeding harmonics into the system that already has harmonics going on to begin with. So, we have to have there's never been a good way to manage this according to the load and the conditions of the power, inside and outside the building. That's what the SP 1000